Okay, welcome everyone. I think it's a good time for us to get started. First of all, thank you for joining us. I appreciate you spending a little bit of time with us. I am Tim Erlin. I'm the VP of Product at Wallarm. And I am joined today by AJ DeBoli, who's from Field CISO at Oracle, who is going to help me talk about NIST Special Publication 800-228, which is all about addressing API security. Couple of housekeeping items before we get started. So we're broadcasting this on both Zoom and LinkedIn. So if you have questions or comments, if you're on Zoom, you can put them into the Q&A on Zoom. If you're on LinkedIn, feel free to put them into the LinkedIn chat. We'll try and pick them up and answer them either as we go or at the end, depending on how things are going. This is obviously being recorded, so if you'd like a copy of it, you can have that. It will also be on LinkedIn. So you can rewatch it, you can share it if you want to see it again, or if you missed part of it, or if you have to leave early, anything like that. And with that, I want to welcome AJ and say thank you for joining me. I think it's going to be an interesting conversation. So welcome.
Hi, Tim. Thanks for having me.
Awesome. Let's get started. So I think before we dive into the details around this particular NIST special publication that came out, it's worthwhile to have a bit of a conversation about why we need to have this conversation at all. What's the point? And I want to start with one piece of data that we pulled from one of our Wallarm's API threat stats reports. So Wallarm does these quarterly threat stats reports focused on API security. We do an annual one. If you're interested in diving into lots of details, you can go to our website and look at them. But this particular fact is one that I think stands out and I like to bring up. And it's that 70% or more than 70% of the application attacks that we see on the Wallarm platform now target APIs. So what does that mean? When we look at attacks across the entirety of the Wallarm platform, we can see that those attacks are targeting web applications or they're targeting APIs. And the split there has now moved decisively to the majority of them targeting APIs, as opposed to web applications. So AJ, I'd love to just start with your thoughts about what does this metric mean? How do you see this shift in your world, for example? Is this important for us to pay attention to? What do you think?
It's absolutely important. A part of me wonders why. When you look at application security and pen testing and bug bounty hunting, a lot of times there's kind of a barrier to entry for people where you have to set up a proxy and you have to know how to use it. And it's pretty easy to make it so that the proxy interferes with your ability to browse the web if you misconfigure it. So it can be a frustrating process, and the learning curve for proxies can be pretty steep. And most of the application security pen testing that I've seen has been largely proxy based. So now with APIs, you can just scan for endpoints. You can use PowerShell, you can use Python, and it removes that barrier of entry for proxy. But I guess the question that I'm wondering is, who are the people executing these attacks? Are there a lot of the maybe script kiddies looking for low-hanging fruit for a bug bounty, or maybe your resume booster through vulnerable disclosure, or are they just wide web scans, or are they attacks specifically targeting APIs?
Mm-hmm. I think you're hinting at something there that's worth sort of pulling out and emphasizing, which is that APIs are designed to facilitate automation and scalability. And attackers, as much as anybody else, benefit from, in their day-to-day job, so to speak, they benefit from scale and automation. So that challenge of, if you're attacking a web application, you're trying to automate that process, you have to, because web applications are designed to be interacted with by a human being, you have to automate that process of being a human being interacting with that web app. But APIs remove that challenge. They're built for automation. So it lowers the barrier to entry, but it also lowers that uh, the barrier to scale and automation as well. Does that make sense?
That makes a lot of sense. Thank you.
Yeah, yeah. No, I think that was in your point. So thank you. Yeah. So I mean, in terms of the why, uh, do you see a corollary shift in terms of development as well? So in other words, is the shift that we're seeing in targets, attack targets being APIs, matching a shift that we see in the broader world in terms of development or deployment of services. Do you know what I mean?
Could you rephrase that? I'm not sure I understand the question.
Yeah. So what I'm wondering is if we are seeing more API attacks in part because there are more APIs, and there are more
Okay.
APIs because people are building more APIs. Web applications have become less the focus in terms of development and delivery of services, and APIs are now becoming that kind of sort of the forefront of how people are building and delivering software, basically.
Absolutely. Thank you for the clarification. Yeah, I see APIs, the adoption and creating more APIs that effectively increase your attack surface. I see it growing kind of like cloud did, or
Mm.
kind of like cloud continues to grow, whereas organizations are using automated functionality to deploy more infrastructure, to deploy more capabilities. Along with that automation comes with there can be a lack of visibility if you forget what you roll out. So for example, in traditional, IT security settings, you have to go buy a server, and then you have to go buy the infrastructure and the wiring around it. You have to get it set up. And in that process, you become familiar with the environment and the architecture. So that's in mind when you have to go protect it. And it's a whole undertaking. Whereas
Mhm.
when you're spinning up more cloud environments and, replicating regions and things like that, it happens so quickly that that opportunity to become familiar with your environment and really understand what's there, and therefore how you need to defend it and validate whether it's decommissioned, that becomes a little bit more abstract. And APIs take that one step further
Mhm.
because infrastructure is rolled out at generally slowly. Infrastructure is supporting usually multiple applications. So that means that the life cycle of applications is much quicker. So as you're iterating quickly and deploying applications through automated tool sets, the sprawl, it grows more exponentially. So as we saw attacks ramp up because of that challenge with cloud, I think we're absolutely going to continue seeing it with APIs and application security.
Yeah, that's really interesting because you can, if you sort of look at the history, you can think about it as a history of sort of increasing velocity in terms of infrastructure deployment and development and delivery of services, from physical servers to virtual servers to cloud to essentially containers and orchestration. Just at every step of the way, the faster velocity eventually becomes the norm, and then security almost is playing catch up, right? Trying to catch up to secure that infrastructure that's being deployed faster and faster. And APIs certainly fit into that, right? APIs would be, although they're not a fundamental change in infrastructure, they're another step in terms of increasing velocity, uh, that basically security has to now catch up to in order to secure. Hmm. And I feel like that kind of brings us to the next slide that I wanted to chat a little bit about, which is about the impact of AI on APIs and this sort of growth in API usage. We can't have a webinar without talking about AI at this point. But do you feel like this this evolution of AI fits into that pattern? Is it the next step in terms of increased velocity for development and deployment? And does it drive the increase in API usage as well?
Absolutely. I see it absolutely turbocharging organizational capabilities to deploy applications, to improve applications, to add functionality, you name it. And with that increased growth, that exponential growth, will certainly come a lot of security challenges. Absolutely.
Yeah. And I want to talk about that word exponential for a second, because I think it gets used a lot, but in this case, it really is applicable.
Mhm.
Um, because we have Gen AI LLMs that people now interact with pretty commonly via APIs, essentially, right? So that ChatGPT interface is essentially an interface with an API back to multiple ChatGPT models. You have AI apps that organizations are deploying that interact with APIs and run on APIs. And now you have agents. And an agent is something that you interact with. It has an LLM component, but it also takes action autonomously. And those actions it takes are going to be via APIs. And so with every agent that gets deployed, you're seeing growth in terms of multiple APIs that agent then needs to connect to, or that connect that agent to other agents, and it really does feel to me like it's exponential growth in terms of API usage. Um, and it seems like you see the same thing.
Absolutely. And I heard somebody recently, with these agent-based AI capabilities, it means that code can make decisions. And that's really interesting
Yeah.
because, as we know, sometimes code isn't even secure, and sometimes the decisions that code's designed to make, there can be bugs. So now that code can make decisions, it's just like this lasagna of capabilities, but also security
Yeah.
vulnerability opportunities. I heard somebody recently liken AI agents to interns with too much caffeine and access to prod. And that resonated with me because I have experienced vendor outages because interns were running prod while the more senior personnel were out on vacation, or it's the holidays or whatever that may mean, but whatever the situation was at the time. But they move fast, they mean well, but they don't know what's off limits, unfortunately.
Yeah, it's interesting. So we didn't plan this, but we just had the RSA show in San Francisco, and Wallarm did a bunch of stickers for RSA, and one of them, if I can hold it up, was this one, which says, "I took your API key and made some decisions," which was specifically about agentic AI. So I happen to have it sitting next to me, and it is exactly that, right? Autonomous decision making, through AI, and that ability to fail at scale as well is certainly a challenge. So just to sort of bring us to a conclusion here, we've we've got AI sort of exploding, taking off, and it's all built on top of APIs. So we're seeing a corresponding growth in terms of the API threat landscape. And I think that brings us to the topic of the webinar, which is this NIST special publication 800-228, which, to be fair, is an initial public draft. So let's just be clear. If after this webinar you feel like you really want to comment on it, I think the comment period ends on May 12th, so you got a couple of days. But this is an initial public draft, but it outlines the recommended controls for API security. And it's always valuable when NIST introduces a set of recommendations or requirements because it gives the industry something to sort of center around. Even if you don't disagree, even if you don't agree with all of them, it's an opportunity to have a conversation about an independent third party set of recommendations or controls for a particular area. And so it's worthwhile talking through them and understanding what's there. Before we dive into the specific requirements, I wanted to bring up just one little side topic about how we talk about compliance and security, because this is also a topic that inevitably comes up anytime you're talking about complying with something. And I think, in my experience, for practitioners who are the ones responsible for trying to buy tools or implement processes that comply with some set of requirements, whether it's something like NIST or a regulatory requirement, it can be challenging to have this conversation about compliance. So I want to introduce a way to think about it. Three terms that you can use, and we'll use somewhere in this conversation as well. And that's provides, validates, and supports. So when you're talking about a process or a tool, and you're comparing to how it's aligned with a standard, you can use these terms to sort of be very clear about what you mean. Does this tool provide the control, right? So if I have a requirement for to produce an inventory of assets, say an API inventory, the tool that creates that inventory for me, it provides that control. A tool can also validate. So you can be compliant, but if you don't demonstrate that compliance, if you're not validating it, that's part of the compliance process, is that validation. So you might have a tool that produces an API inventory, but not one that demonstrates that that's being done in a consistent way and aligned with the requirements. So let's just say you have a requirement that you produce API specifications for all your APIs. A tool that validates, that checks that there's an API spec for every API you have, that would be a tool that validates that control is in place. And then, of course, there's lots of room for tools that just make compliance with a requirement better, and we would put those into the category of supports. So, an example, you might require authorization for every API call. If there's a tool that identifies authorization vulnerabilities in the environment, it's not providing that authorization, it's not validating that every call is authorized, but it's supporting that control by finding those vulnerabilities. So it does something relevant to the control. And so that language can be helpful in just understanding when you talk about compliance with a standard, whether it's this one or another one, uh, you can use that to understand exactly what you're talking about and avoid confusion. So having said that, let's talk about the recommended controls inside of NIST 800-228. What we've done for this webinar, because there are 22 controls, and if we went through each of them one by one, it would be a very boring webinar. You can do that on your own. Feel free. We went ahead and grouped them into some thematic groups that we can talk about, so we can sort of discuss the relevancy of these groups. And the first one is this group of recommended controls that are all around API specification and inventory management. And I think I'd like to start, AJ, with the requirement to just, the main point here is to understand what APIs you have and document them. Why is that requirement to have an inventory of your APIs important? Why is that part of a core set of API security controls?
Well, it's so important because if you don't know what you have, then you can't come up with a strategy to protect it.
Yep. I mean, it seems simple, but I keep hearing it. If you don't know what you have, you can't protect it, right? So we go beyond just discovery, because some of these recommendations aren't just discovery, but there's this idea of sort of defined and documented as being part of the overall discovery requirement. Um, why do you think that NIST has included this requirement to have specifications for APIs? What value does that deliver to someone like you in a sort of a CISO role?
Sure. So with regard to specifications, understanding what these APIs are doing and what sorts of capabilities are being run through them. If old versioning is being used or something like that, it's helpful to know, because oftentimes if you're having an issue with something being outdated or unpatched in one area, you
Mhm.
have that challenge elsewhere. So at the leadership level, you can't have that mindset of playing whack-a-mole. You have to look at your tech debt, your legacy infrastructure, your patch management strategy, and you
Mhm.
have to adapt it to an enterprise mindset. So that way, you are using enterprise level programs and enterprise level controls in order to make sure that things are being reviewed and validated and staying up to date.
Mm. Yeah, and I would think that having specifications allows you to track changes, or at least, well, there are two aspects that come to mind for me. One is in general, you can't know what's supposed to be. You can't know if your environment is the way it's supposed to be if you don't have uh, a document or something to reference that says this is what's supposed to be there, right? The
Mhm.
comparison of what should be in the environment and what's actually in the environment, which is so critical for identifying risks that you should eliminate. You can't do that without a specification as one side of it. uh, and that goes to tracking changes, identifying shadow APIs, things like that. All of that really requires that you have a specification to start with, I think.
Absolutely. And I think this is going to be a huge challenge for organizations. Just having a reliable inventory for really anything has definitely been a struggle, because do you remember NACs? Like, we used to use NACs, network access control devices, to validate devices before they join our network, and it helped us to keep an asset inventory of just physical assets, things you have to procure. You go out, you buy it, you have to get approval, and then you have to
Yeah.
configure it. So these are things that are very visible and tangible. And we would struggle with devices falling off of NACs, right? And
Yeah.
if they fell off of a NAC, they probably fell off of antivirus. And now they're low hanging fruit for ransomware. So now, if you bring that forward with these APIs, again, they're intangible, they're easy to roll out. So where organizations are struggling with basic asset inventory, and then later with software application inventory, this is going to be a huge struggle. And at the very core of it, you need scalable tooling that will discover these APIs and will help you catalog them and will help you keep up with the growth and the velocity at which that they're being created. So I think there's going to be some growing
Yeah.
pains here, but it's great that this is starting to be discussed, and this is publishing guidance. So now companies are like, instead of saying it's in the pipeline at some point, now these requirements are starting to become more real.
It's really that the analogy you brought up there of NACS is really interesting, because if you translate it forward to APIs, if you had the idea that an API cannot communicate in your environment if it doesn't have a corresponding specification, if you just block
Mhm.
everything that doesn't match a spec, essentially, a true sort of positive security model. it would be incredibly challenging for someone to implement most organizations, but it would really limit the attack surface. Just like if you can't add a device, the device can't join the network if it doesn't meet the criteria. Sort of a network access control piece, and that you could apply these requirements that way for sure. Interesting. So let's move on to the second grouping. There are 7 groupings for what it's worth, just to set the expectation. The second grouping kind of touches on that. It's around schema validation and input handling. Um, and the goal here, the objective is really to make sure that the data that goes through those APIs, the data that passes through them, is safe, is well formed. It's what should be there. So we're taking that next step actually from discovery and inventory to validation. And there are 3 recommended controls here. Um, I don't know if AJ, if any of these jump out at you as particularly beneficial or particularly problematic for organizations, but I'd be curious to know if any of them resonate with you in a particular way.
Sure. So one of them does jump out at me, and it's the validation rules and schemas, and really understanding all of the parameters various APIs accept. And one example I heard recently that stuck with me was a vulnerability researcher, so like a white hat guy.
Sure.
He sent in a trade on one of the big cryptocurrency exchanges, and he fired up burp suite, and this was maybe 3 years ago, so this is very recent. So these are highly regulated, hardened environments. And he saw his purchase about to go through. So when he intercepted it in burp, he looked at like what he was trying to buy and the price and everything, and instead of trying to change one of the parameters that would immediately come to mind, like I want to buy Bitcoin for $1 or something like that. Instead, he changed, rather than purchasing Bitcoin with dollars, selling Bitcoin for dollars, he said he was selling something else, and it went through. And that is really
Yeah,
interesting, because the idea of mapping every argument an API takes, some of the things they take are obvious, and we're like, that's what's interesting to attackers. We have to be aware of this. We have to validate this specific input. But it's
yeah.
really easy to forget about stuff that might be counterintuitive, that we might gloss over because we think, who would care about that?
Sure. Yeah, yeah. And there's also the consideration of hidden parameters, right? So if there's a parameter that isn't in a specification, that isn't obvious in the API, but lets you, set a particular call to an admin permission, breaking authorization, obviously, that would be something that would fall into that category as well of input in validation rules and schemas. And in fact, if I look at this, these 3 fit together really well, even though they're not in sequential order. 5, 13, and 22, they fit together thematically because it's like create valid schemas or specifications that include all of the necessary detail, validate that those requests and responses match those schemas at runtime, and then essentially support blocking of malicious or malformed requests. So don't just, you've got to have the right spec, you've got to have inspection of requests against that spec, and you've got to be able to actually take action to block something, not just report it. And those three recommendations actually come through in a pretty clear sort of theme or set of capabilities. If you could implement those 3 things, you'd go a long ways towards securing your APIs. All right, let's jump ahead to the next one. So here we have a huge topic: authentication and authorization. Again, we have recommended controls that aren't necessarily sequential, but come together thematically. And behind this, sort of NIST has an overall objective or theme that sort of drives towards zero trust as a capability. So when you look at what these requirements do, I think they push in that direction in general. But I'll ask you the same question here, AJ. Are there requirements here that you see as particularly challenging or problematic for organizations to implement? The ones that people are going to worry about?
I would say authorization. Authentications it's gotten so much better because a lot of orgs are using SSO, you're using OAuth and federated identity. But authorization is incredibly challenging. And it's interesting because with APIs, if you If they don't check for authorization, you can just tell it that you're admin, and now it almost removes the need to perform privilege escalation, because why do you
Hmm.
need the privileges of an administrator if you're granted the same access as a non-administrator?
Yeah, yeah. There was an incident that occurred recently with Volkswagen and the ability to retrieve location data for a vehicle. And it was an authorization issue. So you as a user, an owner of a vehicle, could authenticate to this service, and it would give you all the location data it had for your vehicle. But you could also swap a parameter in the JWT and the JOT for a different user, and you could get location data for other users. And that's a classic sort of authorization issue, right? You're authorized to get to this API endpoint, but it should be authorizing every single call against the users who have access to that specific data. And that I think you're right. That's going to be a huge challenge, or is a huge challenge for organizations, for sure, definitely. The other one that jumped out at me here, I think it was this one. Uh, No, it's essentially the same thing, right? So the authorized access for both identities and the specific action is that detailed level authorization. And then enforcing field and resource level authorization using schema tags is the functional level of that authorization. So I think they kind of just come together. But we continue to see broken authentication and authorization issues as some of the top issues from both an API vulnerability standpoint and the actual attacks that we see in the platform as well. All
That's
right.
great. One more
Yeah, go
thing
ahead.
that I found interesting here is these are hard to detect. If authorization is bypassed, we've been lucky with ransomware, and I know I sound ridiculous saying that, but with ransomware, something is wrong in your environment, and it's time to fix it.
Yes.
The authorization concerns are a lot scarier because they're quiet. And it is very difficult to detect if somebody that hasn't authenticated can bypass that or pretend to be somebody else. And they don't need to really do much in the way of authorization. They just get access.
Yeah.
That behavior versus the behavior of the person or service that typically acts in that role might not be that disparate from that of an attacker. So it's really interesting in terms of how you set up visibility and detection for these types of exploits.
Yeah. Yeah. And two things. One, you're absolutely right. Ransomware is one of the few, if not the only type of attack that has to announce itself to be successful, right? You can't collect the ransomware without being caught, without being, identified as an attacker. Um, and the authorization issues are so hard for tools to detect because they require an understanding of the business logic of who should and shouldn't be allowed to access what. And that's challenging to build into a tool for sure. Okay. So the next category is around sensitive data identification and protection. We've got three recommended controls here. The objective here is, to focus on that sensitive data flowing through APIs and their endpoints. Tracking, filtering, securing it. And here, there's some interesting, um, sort of interesting requirements around both identifying sensitive data, so that's the first one, and then monitoring and applying policy based on that sensitive data. Um, AJ, do you have any particular thoughts about how sensitive data flows through APIs? I mean, obviously, if you're building an API that does something like it's a billing API. It's going to share credit card data because that's what it does. So we can't keep sensitive. It's not about keeping the sensitive data out of APIs. It's about identifying it and managing it. Do you see this as a challenge, or is this something that you feel like organizations have a pretty good handle on?
It's definitely a challenge. There used to be tools out there that we would use all the time to make sure that social security numbers or PHI was not places we didn't expect it to be, and inevitably we would always find things. So tools like that, I see them being difficult to scale and deploy
Hmm.
through APIs. I see that as kind of a growing pain. But also, just taking a step back, there are challenges in how organizations recognize and define their sensitive data types. Of course, security has to support the business. So taking a business and regulatory based approach to labeling data and treating it in a particular way, it certainly makes sense.
Hmm.
But recently, Colonel Tetro from the Rhode Island National Guard, he's with CISA now, was telling a story to an audience where an organization had their insurance binder unencrypted for cyber insurance. And they didn't think it had any value to an attacker, but what it stated was that their policy would pay up to $2 million. So when an
Yes.
attacker saw it, they said, okay, 1.5 million, they knew it would pay out. So
Yeah.
that
Yeah.
is, yeah. So to me, that's an example of maybe we should reapproach how we're looking at how we define our sensitive data, maybe be a little bit more creative and save ourselves some grief and some breaches in the long run. It's not always obvious what's sensitive.
Yeah, it's a great example. I think you're right. There are of course defined sensitive data types like PII, PCI data, PHI, but that's not the extent of all the data that's sensitive to your organization. So being able to starting with, what data is sensitive to my organization, knowing what that is, and then being able to identify it in APIs, is really, it's an extension of the maybe the basics here. Implementing the basics is always important and good, but there is something more to consider. I agree with you 100%. All right, let's take a look at access control, hygiene, and request flow. So, it's interesting because we had a separate sort of section on authentication and authorization. Um, and I grouped these two controls together because while they're a little bit related, they did seem like there's at least a bit of a separation. The focus here, or the objective here, is sort of on hardening that API behavior, making sure that the sequences are correct, and being able to enforce, um, blocking specific users or tokens. That requirement stood out to me, um, because it reads enough like, uh, it's targeting a specific tack, right? It's a specific problem that occurs in the real world, where you have or tokens that have been compromised. AJ, have you seen that challenge anywhere in particular? Has anything come to mind for you? I realize I'm
I've
putting you on that spot there, but
yeah, of course. I mean, not yet within the context of APIs. However, I have seen issues where a token is compromised and the
sure.
security team needs to block tokens mid-incident. And that assumes that the security team knows which tokens are causing trouble and they have the tooling to respond quickly. And the reality is, for a lot of organizations, I mean, that's a mature capability. So that will certainly be a challenge. It's great, to your point, that they call it out specifically. So people who maybe haven't dealt with that or experienced a similar issue with tokens might look at that and say, it's interesting, this is specifically called out. Maybe this merits some more attention. But the enforcement of it in practice will certainly be a growing pain.
Do you I don't know if I want to ask you a question or put a thought in your head. One of the two. So, when you look at the cybersecurity incidents that have occurred over the last 5 years, I think I'd have to go double check the data, but I think there's a pretty clear trend in uh, in that stolen credentials, lost or stolen credentials, is one of the primary causes. I'm thinking of the Verizon data breach report that comes out annually, and I think it's been at the top of the list for a long time. Um, and if I think about it, I can't help but see an analogy or sort of an evolution here. If, stolen credentials are the way that attackers like to get in, but applications are moving towards more and more APIs, are we going to see, or maybe we're already seeing and just not tracking very effectively, compromised tokens or API keys being sort of that next primary attack methodology for those attackers who, if the usernames and passwords aren't good anymore, but I've got lots of APIs, should I just start stealing API keys?
Absolutely. It's funny you mentioned that because there was some guy on Reddit like maybe a week or two ago, and he had this headline where it said, like, I made $50,000 in a week by scanning for leaked secrets in deleted files on GitHub. And, it's the internet, so you have to take it with an enormous grain of salt. However, I don't I see that as an opportunity,
Yeah,
not only for,
an
token
opportunity for the attackers or an opportunity for us, for the practitioners.
opportunity for everybody. Once you get attacked, you can definitely get some more funding, um, as long as it's not a resume generating event. But I thought that was really interesting because I'd always thought about people accidentally leaking, API keys and tokens and things like that on GitHub. But I had forgotten that even when you delete things, you have to delete them in a specific way. So there's probably repos and all kinds of things all over the internet where if somebody was creative
Yeah,
enough, they could do some crawling and they get keys to a lot of kingdoms, to your point.
yeah, yeah. There was an incident in Q1 of this year, last quarter, with I think it was with DeepSeek. No, sorry, it was with the Common Crawl data set, which gets used to train a number of LLMs, and that Common Crawl data set contained a whole bunch of essentially API keys and tokens that it had picked up in its process of crawling data for training LLMs. So that the data is definitely out there, as you point out. We've got a question here that I'll throw in because it's relevant to this slide. With APIs, what concepts are there to identify programmatically when a user is unintentionally misusing an API call and trying to access data they don't have access to versus a malicious attack? Are both treated the same? Uh, okay, so the question here is if I rephrase that a little bit, how do you tell the difference between um, a user who's unintentionally misusing an API call and an attacker who is intentionally misusing that API call? In theory, I suppose in the same way. I've got a few thoughts about that, AJ, but I don't know if you have an immediate thought there.
Sure. I'm really interested in, because you have more, working for a vendor that specializes in this, you probably have more visibility into this than I do. But to me, the two things that jump out is, user behavioral analytics. So maybe.
Hmm. Hmm.
And then also geographic. Lots of times we'll see personnel log in from a country where an organization does not do business or something
Yeah.
like that. But those are obvious. In terms of the less obvious types of attacks that the questioner is referring to, what do you see?
Yeah, I mean, to be clear, I think it's difficult to tell the difference because if the behavior is the same, misuse of a call, of some API request, um, it's going to be difficult to determine the user's intent, whether they're an attacker or a user unintentionally misusing that particular API call. The reality is that misuse of an API call by a legitimate user is fairly rare because APIs are generally used programmatically. um, I mean, it's going to depend on the situation. If you've exposed an API for people to use, you might have developers who have written some bad code. Maybe they had AI write some code for them and it didn't turn out quite the way they intended. That could be misusing that API call. But if it's your application connecting to that API, then you should know how your application is using it. I'm thinking of actually a customer example we had where we picked up what looked like um, API requests that violated the spec actually in this case, and the customer said, no, that's not the way our mobile app authenticates. This has to be an attacker because our mobile app doesn't work that way. It doesn't use this parameter that isn't in the spec. But lo and behold, we found out, yeah, actually the mobile app does work that way. And so as soon as we started mapping the request to the spec, we found out that the mobile app was out of sync with the spec and what the security team understood the spec to be. So in that case, it was not malicious, but it was their own application. So it's challenging there. You can do some aggregation of that user's behavior to try and determine what they might be trying to accomplish. So if it looks like an account takeover attack, then you can sort of infer some intent there as well. So, but it's a challenging thing to accomplish. Okay, let's keep moving forward. I've lost track of what number we're on here. I think there are two or three more left, but they're all exciting, so don't worry. Rate limiting and API abuse prevention. So here we've got the objective of protecting against denial of service. Something that's important for APIs is cost amplification. So if your APIs are integrating with third-party services that have a cost component, for example, calling out to ChatGPT's API as an example, you can have API attacks or misuse that actually have a material cost to your business as well. And of course, other types of automated views would fit in here too. And I think AJ, in an ideal world, where would, if you think about usage limits, rate limits, payload sizes, in a perfect world, where would those things be enforced in the infrastructure?
I'm not sure about a perfect world, but I've seen an imperfect solution that a
All right.
lot of people have used in the context of cloud, because you have a similar challenge with cloud. If a malicious actor gets into your environment, they can spin up a lot of computational
Sure.
resources and consume just so much. They usually mine for cryptocurrency or do something like that. And it can be very costly, like hundreds of thousands of dollars in days. So not only do you have to put limitations on, what sorts of things can be spun up by whom and quotas and things like that. I've seen a lot of people set up cost tracking as an early warning sign, and it's
Oh
not
yeah.
infrequently a canary in the coal mine. So where should it be enforced? It's tough because I can see the importance of rate limiting. I can also see if you broadly apply rate limiting across your environment, you might have some undesirable results. You might have
Mm-hmm.
some calls that need a higher rate limit, or that would be immediately shut down. So maybe as kind of a temporary fix, having some sort of a cost monitoring control is helpful, because then you also have more eyes on it than just your security and application or business owner teams. You usually also have notifications to finance too, and they tend to keep a close eye on things.
Yeah, yeah. And I think that you're right. And you touch on an important point is that there are multiple places that you can and probably should put in place usage limits or rate limits, whether that's in the application itself or the service itself. Obviously, if you're developing a service, you want it to fail gracefully and implement its own limitations, but that's not always the case. So implementing it in a third control, they call out WAF, bot, and denial of service defenses here. API security tools as well. If you can put in place tools that apply those kinds of rate limits in the traffic, if they can do it generically or specifically or both, you're going to get the best performance there, and you're going to have the most flexibility in terms of how you adapt to the threat environment as well. All right, this is the last one that we have here: observability and logging, which gets one requirement, or one recommended control, and I feel like that's not enough. So if if you want to think about comments that you might provide back, uh, I mean, you could have a whole set of whole NIST publication on um, you know, log management, tracing, that kind of thing. But it is incredibly important to have that telemetry. Without that telemetry, you're missing context is really what it comes down to, I think. AJ, what do you think about this one?
I wish that wherever we called out observability, we called out the so what. So if you had the
Yeah.
capability to observe every bad thing that happened in your environment, or let's to make it simple, you have one really awful thing happen in your environment per year. So even if you get alerted to that and enough time to intervene in an ideal situation, would you be able to do so? Do you know the token that's being abused? Do you have access to the environment where malicious behavior is occurring? Can you detect lateral movement?
Hmm.
um, After an initial compromise in order to effectively contain a threat. I wish there was a so what here. To me, if I had to add in a so what, definitely work API threat use cases into tabletop exercises. Build that muscle memory with your teams where they know how to dig through that application layer data, and they know who to call. In large organizations, sometimes small application teams, they might fly under the radar. They might be in a different time zone. You might not know who to reach out to. So having those communication channels open and understanding how to respond is really the key here, because knowing something is happening versus being able to do something about it are two entirely different capabilities.
Yeah, that's really interesting. I had a medical doctor once say something to me like, it was about doing a diagnostic test, and said, well, the test doesn't change the outcome, so why would we do it, right? it it doesn't matter if you can't do anything about the information, then it doesn't matter whether you have that information or not. Which is an interesting it's a really interesting challenge for information security as a whole, because we're often so focused on getting the information, um, that we lose track of the what are you going to do about it? What can you do about it? What capabilities do you actually have to respond? I think that's actually really insightful and a huge challenge for sure. All right, excellent. So that's the last of the requirements in the 7 groups that I mentioned. I'm going to spend a little bit of time talking about how Wallarm can help here. We'll dive into just a quick couple of slides on how Wallarm aligns to those requirements. And I told you that we would bring back that provides, supports, and validates language that I introduced at the beginning. So I'm bringing it back here. So across these groups, I've labeled where Wallarm provides a control and where we support the control in some way. And I'll give a little bit of detail here on each of those. So when we talk about API specification and inventory management, Wallarm is that tool that can create an inventory of all your APIs for you. It can also produce specifications based on the traffic that it observes in production. So it's built around traffic analysis, and if you're missing specifications, they can be produced. They will match what's actually in the environment at the time. It also gives you the ability to compare specifications to identify those rogue APIs, things like shadow APIs, an endpoint that's in the environment but not in the spec, as an example. When we talk about schema validation and input handling, Wallarm does provide the capability to actually enforce API specifications. So if you want to block requests that don't conform to the specification, Wallarm can do that for you. Parameters that are missing or undefined endpoints or other items that might be in the spec are there as well. When we talk about authentication and authorization, Wallarm is in a position to support those requirements. So Wallarm doesn't provide authentication and authorization, but we do identify authentication-based vulnerabilities, so we can find broken authentication in the environment. We can also detect different types of attacks that are targeting authentication and authorization, things like account takeover and credential stuffing attacks as well. And if we move on to the last of those groupings of controls, with sensitive data identification and protection, Wallarm is also in a position to support that. We will identify sensitive data in API requests and responses. So if you're looking to understand where that data is flowing through your environment, whether it's PII data, financial, or if you want to create your own custom patterns to look for in API requests and responses, Wallarm can absolutely identify that and tell you where that data exists in your APIs. Around access control, hygiene, and request flow, Wallarm can provide requirements there. We'll detect various types of authentication and access control abuse. We'll also block or can block specific users or API keys from being used in production. So that conversation about blocking the use of a key that you know has been compromised is something that Wallarm can provide. Wallarm can also provide rate limiting and abuse prevention. So both generic rate limits, but also very specific rate limits around APIs. So if you want to implement a rate limit on a specific parameter or specific header in a specific endpoint, Wallarm can do that, which can be pretty useful as well. With observability and logging, Wallarm supports that. We're not going to be a logging solution for all of your APIs, but we do capture information about every request and every session. So you can actually see the context of what occurred around an event, around an attack. If you want to review every request in a session to see what the attacker was doing before or after they ran an exploit that was detected or blocked, Wallarm can do that. If you want to investigate sessions that are suspicious for some other reason, Wallarm can help you investigate those sessions as well. So lots of great capabilities there to help support those NIST requirements. And with that, there is a data sheet if you want more details around how Wallarm lines up, and that grouping of controls that we talked about is also the grouping that's in that data sheet. So if you're interested in that, you can grab that there. I'll remind everyone now, if you want to ask questions or if you have questions, feel free to put them in the chat or in the Q&A, and I will take a look and see what we have from a question standpoint. I know there are a couple in there. So the first question we had is, how are adversaries benefiting the most from API attacks? AJ, did you have a thought about that? Like why, I think we touched on a little bit, but why are adversaries benefiting from APIs, or how do they benefit from those attacks?
Sure. Well, primarily it's the low barrier to entry. You can go out there and you can find them pretty easily. I've even seen situations where people will go through an organization's documentation to see which API endpoints are documented,
Mm.
versus and then they'll run a scan and they'll do a diff. And so whatever isn't documented is probably unsupervised and undetected. So it's that low barrier to entry. But in
Yeah.
terms of how are they benefiting, how are they monetizing the access they get from API attacks? I can't speak to that specifically. I assume it's probably however they monetize all types of attacks. They exfiltrate data and they sell it, whether it's PII, PHI, maybe the values in the aggregation of data, maybe the values in the access alone.
Hmm.
What do you think, Tim?
Yeah, a few years back, I did sort of a deep dive on how attackers monetize, sort of stolen personal information. Because I had the same question, right? You hear sort of the two ends of it. You hear the data was stolen, and sometimes you hear about identity theft at the other end, but there are a bunch of steps in between. Like that data gets sold multiple times, it gets cut up, it gets divided into higher and lower quality, and there's an economy around it. So the primary reason from my or primary way from my perspective that attackers benefit from attacking APIs is that they get programmatic access to data. It, APIs are designed to share data. They're built by developers who built them to share data programmatically. And so you tend to get faster access to a cleaner set of more complete set of data than doing something like scraping a web application, where you're going to get partial data. You're going to get the data that's displayed, not the data that's served up by the API behind it or by the database behind it. So I think there's a clear benefit to the attackers in terms of attacking APIs. All right, we've got another question here. Are you talking about tokens between endpoints and public APIs or machine-to-machine API keys, such as the ones you use for administrating your AWS infrastructure? And then there's a question about sort of capabilities here. But let's start with that first question of what kinds of tokens or keys should people be concerned about? Just the ones that are between endpoints and public APIs, or the machine-to-machine API keys as well? What do you think, AJ?
Well, yeah, if you're embracing, the concept of zero trust, all of them, really. It's clear, it's easy to see how the public ones obviously require more hardening and maybe more immediate attention because they're kind of that welcome mat into the environment. But there's a number of ways an attacker can get into an environment. And once they're there, if there are APIs that are easily accessible from inside, they're going to leverage those, whether they get in
Yeah.
the environment from an API or from leaked user credentials or brute forcing SSH. I mean, there's so many ways to get into an environment. And also, you're really facilitating access to information once you get past that first checkpoint. Once you're in, now attackers, if your APIs are not hardened or monitored, they have an easy way to move around and move data around. So I would say, I guess if I had to pick one, of course, the outward facing ones would be more important. But don't sleep on those internal ones because they really can accelerate an attack and drastically increase the impact.
Yeah, you mentioned earlier in the webinar somewhere, the idea of lateral movement, and I think those internal API keys, whether they're inside of AWS for managing infrastructure or inside your organization for internal APIs, they do facilitate lateral movement for attackers. They facilitate access to additional data that they might not have access to otherwise, and so it is important to protect them. You certainly can't leave them behind. But you're right. In a world where we have to prioritizing the things that are publicly facing is certainly a reasonable thing to do. Okay, I think we covered all the questions that we've had at this point. So I want to thank everyone for spending time with us. Hopefully, it was interesting and useful. I think we'll see more on this particular NIST publication in the future as it gets adopted, as people talk about it more. So, it's an opportunity to get a jump start on it. AJ, I want to thank you in particular for joining us and sharing your expertise. It was really valuable. I found it valuable. Hopefully, everyone else found it valuable as well. And with that, thanks for joining us, and please definitely join the next Wallarm webinar. We'll continue trying to produce webinars that are interesting and useful for you. So thank you, AJ.
Thank you, Tim.